Okay, good afternoon, Greg and examiners. My name is Derry Brennan, and I'm going to talk you through my final exam alternative logbook. So, starting out, I just wanted to explain to myself the tutorial that we're being asked to do, and basically an introduction for new people into machine learning and artificial intelligence to give them a run through of some algorithms that they might find useful. I moved on to trying to decide what platform I was going to use it on. We're going to use Python as the language, but I had the decision between just a flat Jupyter notebook or Google Colab. I'd previously tried to use Google Colab in a group project that I'd done, uh, but it didn't work out. So this time around, I said I'm going to come back to it and give it a go. I figured that this would make it far more shareable if somebody wanted to use my tutorial, that they could just have it on Google Colab and they could mount their own Google Drive and follow along and make alterations as they saw fit. So then moving on to data pre-processing, it's an extremely important part of any machine learning project, as can be seen here in the CRISP-DM model. And so from the business understanding, data understanding, and data preparation, these are iterated over quite a number of times, and their importance is always not fully understood by new people coming in, just how much you stay in these phases. So I wanted to go through some of the more kind of common data pre-processing techniques with the newer people, just to give them an introduction into it, to see what features we want to think about and what features we don't want to think about, and ways to deal with missing values and such. So that's just a quick section as we progress on through the different algorithms in the tutorial. Different data pre-processing techniques will be gone over and explained in their relevant sections. So the first algorithm I decided to implement was a decision tree. I felt that this is a very good starting point for newer people. I selected a mushroom data set, and I was going to classify whether a mushroom was edible or poisonous based on the features within it. All the features within the mushroom data set were character based, and they need to be numeric for the decision trees. So I used a kind of a homebrew method of converting those characters into numeric values, which turned out not to be great because my overall accuracy for this one came out to be 100%, which I felt was erroneous. So on reflection, I decided to leave this in here as a kind of a cautionary tale, and repeat the process with a different data set and using a proper label encoder from sklearn to convert non-numeric values into numeric values. This had a much more proper outcome, the accuracy being 91%. It's not perfect, but nothing is. And then afterwards, I kind of decided after decision trees, the only way to go is random forest. It's a direct continuation, being a grouping of decision trees and their outputs all coming together for a majority voting to decide what the ultimate decision will be. In this one, I selected a bankruptcy data set, and we're going to predict whether a company will go bankrupt or not based on its features. This data set had a huge 95 different features in it, and because of this, I used a function called recursive feature elimination from sklearn. This basically trains up the model, and it selects the features that are most pertinent to selecting your class. And then you can hone down your data set down to those features that are most pertinent. There was also some oversampling techniques brought in here as well. Then onto K nearest neighbor. I used a heart failure data set here. I kind of felt that this was a good logical continuation from the stroke data set in our decision trees earlier on. I had a little bit of problems graphing this one out, but it was all right. I ended up selecting a K of 3 for the K nearest neighbors. And the overall accuracy came out to be 71.6%. Then onto naive Bayes. This is using a mathematical function shown here below to predict the likelihood of something based on examples already provided. For this one, I used a text message data set called the spam data set. This had a grouping of text messages, and they were either marked as spam for unwanted ad messages and such, or ham for proper messages that you want to receive. From a data pre-processing point of view, I introduced a new idea here of removing stop words. So stop words are words that add no meaningful value to a sentence. So we were able to take out words like a, and, but, how, etc., and then store the rest of the text in a list for the algorithm to be able to easily compute over. So this one came out quite good. It was 94% accurate in predicting the spam messages and 99% accurate in predicting the good messages. And then onto the convolutional neural network. This was an algorithm I tackled previously in a group project. We're doing a binary classification of breast cancer tissue samples. But for this one, I wanted to kind of go a little bit deeper than just the binary classification. So I found a data set that had iconic women throughout the centuries on it, with 64 different iconic women within it. So I was going to try and predict from 64 different classes for this one. There was a lot of kind of data or image normalization and image manipulation to kind of tilt the images, zooms and flips as we were putting them in to the model. The overall accuracy of this one wasn't to my total liking. It came out at being 38% accuracy. Out of the 64 possible classes, though, if somebody was to pick at random, it would be like a 1.5% chance of picking the right one. So it was still 24% better, or 24 times better than purely random selection. I feel that I could have worked a little bit more on bringing this one up to a standard where I'd be happy with, but this was the last one that I came to, and unfortunately time was running out. There were things like the dropout layers added, and that did improve it, bring it up a bit, but there was more that I'd like to go into in depth here, but unfortunately time constraints led to finishing up at this stage. So in conclusion, it was a great experience. I learned a lot myself, and I hope I'll be able to pass on some of that information on to other people. One of the things that I'd like to point out was the Humble Bundle Machine Learning Zero to Hero group of books from Manning Publications. It was great help in kind of giving me inspiration and guiding me to how I wanted to do things. So videos on YouTube, I've linked them in the tutorial as well. There's some data pre-processing videos here, and I've inserted one for every different algorithm as well. So that's my my logbook gone over. So thank you very much, and I hope it's enjoyable.